Howdy, I am going to be demonstrating the topic of equilibrium by solving an equilibrium equation. What we're going to be doing is, given hydrogen gas and bromine gas in a flask, we want to find the concentration of each species present in that flask at equilibrium. So to do so, we are given a balanced equation, as you can see up here, and we're also given the equilibrium constant, Kc. The very first step that we need to do is write our equilibrium expression. And so we have the Kc equals 64, and that's equal to the products multiplied divided by the reactants multiplied together. So here we have HBr squared, because we have that coefficient of 2 out in the front, divided by the hydrogen times the bromine. Products divided by reactants. Our next step is to once again write out that balanced equation and use it to create an ice table. And what that stands for is we have the initial concentrations present of each of these. Then we want to have the change that's going to occur in the concentrations as we move towards equilibrium. And lastly, we want to have the equilibrium concentrations. And so as you can see here, we were given 0.010 molarity of the hydrogen and the bromine gas. And because our reaction hasn't proceeded yet, at the initial point, we have 0 molarity of the hydrobromic acid that would result. Next, we are going to have our change. So once again, because we have that coefficient of 2, we are going to add 2 times x to that change. And then in the reactants, we are going to flip that sign, and that's going to be a negative x. Our coefficient is 1, so it's just negative x. And then we're going to combine that. We're going to do 0.010 minus x for these two, and 2x, because 0 plus 2x is just 2x. In the very next step, we are going to take these right here, and we are going to plug those in to our equation. And I'll do that next. All right, so once again, we have our ice table, and we solved for x to get 0.008 molarity. And then lastly, we're going to plug that into the E of the ice table. So for hydrogen and bromine, we have 0.010 minus 0.008. That gives us a concentration at equilibrium of 0.002. And then lastly, for the hydrobromic acid, we have 2 times x, 2 times 0.008. That gives us a final concentration of 0.016 at equilibrium.